In our last video, we recapped these important concepts. So the measures of central tendency when we are given a whole lot of data. The mean is the average of all the data scores that we're given. The mode is the score that appears the most frequently. And the median is the middle score in a set of data that has been arranged in ascending order. Okay, don't just find the middle score. Make sure that your values are in order from smallest to biggest. Okay, now we're going to start applying these measures of central tendency to all kinds of data. It gets interesting. So here's a look at the different types of data. And the reason why I want to just look at this is because it's important that when you read the question, you know what your teacher means when she talks about or he talks about the different types of data. Okay, so we can get raw scores, which are important, and we are even going to build on the concept of raw data before we move on from statistics. But raw scores, that's literally where we can just plus them all or, put them in order and hop around and find the middle. And then you get data that's organized into a frequency table. Okay, this organized data is not necessarily the same as grouped data. Okay, here, let's say I have had a look at, I've held a competition for the past 2 weeks, and someone in my class has won 10 times, and certain students in my class have won 11 times. And then there's a frequency. 15 students got a score of 10, and 22 students got a score of 11. That data is organized, and if I were to write it out, I'd have to say, okay, the score was 10, and I had 15 of them. So 10, 10, 10, 15 times I would write that. And then I've got a score of 11, and that happened 22 times, etc. Okay, so that is not the same. If I were to expand it like this, then I'd have the raw scores. And in our last video, we actually looked at working out the mean and the median and the mode of data that has been organized. But then we get something like this, where the data actually gets grouped into what is called a class interval. So between 0 and 50, I had 98 people. Now, if I wanted to unpack this data, it's not as easy. I know there are 98 scores, but I don't know if the person got 1 or 49 or 25. Who knows? But they are somewhere in that class interval, in that group of data. And so it's important for us to know how to work out the mean, median, and mode if the data comes raw. If the data is organized, it's important to know how to do it. So if you missed that, go watch the previous video. And it's important for us to know how to work out the mean, median, and mode of data that has been grouped like this into class intervals. And that's what this video is going to focus on. So here we have an example. It says, determine the following for the grouped data below. So straight away I can see data has been put into groups of 10. We are organizing people by age, and they want us to work out the modal class interval and the median class interval. Okay, so mode we know means most, and median we know means middle. Okay, but I need a little bit more information to go on. The first question is straightforward. The modal class, that's the one that occurs the most. So in other words, this is going to be the one with the highest frequency. Okay, so having a look at our data, 6, 4, 3, 7, and 5, there's the highest frequency. Okay, so 7 people scored between 30 and 40, and so the answer there to the modal class, and see how they called it class interval and not just mode, is because now we can say, okay, well, somewhere between 30 and 40. So it could be that I had a lot of 37-year-olds, I don't know, but somewhere between 30 and 40, that's where the most of my participants featured in terms of this data. Okay, but the median is a little bit more tricky, and we're going to have to do some work to get to it. Okay, so what you'll see is that I've added another column here, and also what is helpful to me, probably more helpful when it comes to working out the mean, but here I've added a sum of the frequency column. Okay, and it's good for us to get used to this. So this here is a Greek letter known as sigma, and it means sum of. So they want me to add everything up. So to say 6 plus 4 is 10, 13, 20, 25 scores in total. That's what the sigma is telling me to do. Okay, now in order to find the median, I actually need to know how many people there are in this data study. Because can you remember from our previous video, we could work out the median position by taking the number of data scores, by taking half of the number of data scores plus 1. Okay, so the fact that I've just worked out the sum of the frequency there helps me, because that tells me there were 25 people in this study or in this data set. So a half times 25 plus 1, in other words, a half times 26 is 13. So the 13th person is actually where my median lives, okay, or is my median, but I don't know where that person lives. And so that's why I added another column here. We're going to call this the cumulative frequency column. Now you should have been introduced to this at grade 8 level, and that's where frequencies start to accumulate. So basically we had 6 people by the time we reached 10 years old. Then we added another 4. So 6 plus 4 is 10 people by the time we reached 20 years old. And then we added another 3 people somewhere there between 20 and 30. Okay, that helps me because the first 6 people are sitting here, then another 4 are sitting here, and then another 3 are sitting there. But have a look what happened. I have actually identified position number 13. It doesn't always work out so beautifully, but I have actually figured out that the 13th person is somewhere here between 20 and 30. Okay, let's finish the cumulative frequency because it's good to finish what you start. So we add another 7 people here. We add another 5 people there. A good check is, does this equal that? Then you know you've done something right. Okay, but we can see over here, our 13th person, according to our cumulative frequency, lives somewhere there between 20 and 30. Okay, so this person is, maybe 24 years old, but all we need to know is the median class interval. So therefore, the median class interval is equal to 20 to 30. Now, let's take the same data and we want to work out the mean. But you'll see that the wording on your test and exam papers is going to change just a little bit. We don't get asked anymore just for the mean when the data is grouped, okay? We get asked for the estimated mean because, like I explained earlier, we don't know if the 6 people living here are 1-year-olds or 9-year-olds. We can make an educated guess, but we don't know their exact age. And so that's why, to the best of our ability, we're going to keep it mathematical, but we're also going to be realistic and we're going to say it's an estimated mean. Okay, but I'm going to need a lot more space to do some more calculations, and so I'm adding 2 more columns to our table here. Okay, we know that the sum of the frequency here is 25, and now we've got some new things here. Okay, the first thing is the midpoint of data. Okay, this is where you add the class boundaries, so the lower plus the upper boundary, and you divide by 2 to give you the midpoint. So if I wanted to work this out, it would be 0 plus 10 divided by 2, and that gives me a midpoint of 5. Okay, 10 plus 20 divided by 2 gives me a midpoint of 15. 20, so I'm literally just taking the boundary plus the boundary. 20 plus 30 divided by 2 gives me 25. And usually once I've worked out about 3, I can start to see a trend. I'm just adding 10 each time, so 35 and 45 there. Those are my midpoints. Okay, the next column here, if you remember that midpoint gets represented with an X and frequency is represented with an F, then actually you should be able to just work this part out logically. It's the frequency times the midpoint. Okay, so essentially what I'm doing is I'm saying to give you a good estimate of the mean, I'm just going to assume that everyone in this class is actually at midpoint level. Okay, so let's assume they're all 5 years old here. They're all 15 years old, because what I'm doing then is I'm just trying to work out at least the average. You know, I'm saying, okay, well, if they're very young ones and very old ones, at least we're trying to balance it out in the middle. Okay, it's an estimate, but it is the most accurate estimate we can get. So this one here is going to be my frequency of 6 times the midpoint of 5 gives me 30. This one here, frequency of 4 times the midpoint of 15 gives me 60. And we're going to continue like that. Frequency of 3 times midpoint of 25. Frequency of 7 times midpoint of 35. And finally, frequency of 5 times midpoint of 45 gives me 225. Okay, so that is the frequency times the midpoint. Now, it's not essential that you show these calculations here that I've included. Okay, that was more just sort of to guide us. You can just put the answers, but there is no harm in showing as many calculations as you want to, so that I will leave entirely up to you. If you want to include your calculations, your teacher will probably not complain about that. Okay, here is our sneaky little sigma sign again. Remember, that meant sum of. So what is this telling me? It's telling me that I need to sum the frequency times the midpoint answers. Okay, so in other words, 30 plus 60, let's pick up our calculators and do that. So 90 plus 75 plus 245 plus 225. Okay, so the sum of that is 635. That's what I'm getting there. Okay, and now I can actually work out the estimated mean for this data. The equation of the estimated mean is given as follows. So x bar, that's our fancy way of saying mean. Okay, sum of the frequency times midpoint, so that's this last column here, over the sum of the frequencies, okay, which is sometimes just known as n, the number of data scores that we had before we put it into this grouped table. Okay, so we are getting there, grade 10s. We are now going to take the 635 that we had there as the sum of the frequency times midpoint, and then we want to just divide that by the 25. Okay, so 635 on the calculator divided by 25 gives us an estimated mean of 25,4 years. Okay, so there we have it. If we didn't have this table, we most certainly would have struggled to actually estimate this mean in a way that is accurate. Okay, so my word of caution to you is don't read a question like estimated in maths and think, oh, well, let's have a look. It's probably here 20 to 30. That's definitely not what they mean. Okay, often you will be given a longer table, but just as often or equally as often, you will just be given the groups and the frequency column, and your teacher will expect you to know that if they ask for the estimated mean, you need to then add a midpoint column and add a column where you multiply the frequency by that midpoint. And then once you do that, you can jump here to the formula. The formula x bar is our representation of mean, okay, is equal to the sum of all these calculations that we've been doing divided by the number of scores that we had. And there we have an estimated mean. So there we have it, grade 10s. At grade 10 level, we can have a modal class, the one with the highest frequency. We can find the class or the interval where the median is in, and we saw that was here between 20 and 30. And then finally, we can work out as accurately as possible an estimated mean of the data that we've been given.